Marine accidents always endanger human lives. In designing ships, the first principle is safety first. The engine and the power transmission mechanism, the heart of the vessel, must operate with maximum safety for the crew throughout the 20-year lifespan of the vessel. Gears have long been employed exclusively for power transmission in ships. In the shipbuilding industry, only the courageous builder dares to design the unconventional, and only the pioneering owner dares to accept it. The engine designer of Japan's leading shipbuilder, which first adopted roller chains, said this: "By replacing gears with roller chains, we can achieve more economy and more freedom in design, because power can be transmitted to the shaft wherever it may be located." But since the roller chain itself is a complex mechanism, it sometimes resonates and vibrates in unexpected places. Seizure sometimes occurs at the pin or the bushing. Sometimes the link plate or the roller breaks. So we face complex problems in maintenance. The designer continued, "Both roller chain and gears have their merits and demerits, and it's hard to say which is better. But we designers are confident that the roller chain is definitely more advantageous. In the early days when we began using it, however, we faced a number of difficulties." We had to settle such problems as quality requirements for the link plate, for heat treatment, the clearance between the pin, the bushing and the roller, lubrication, and many others. We settled these questions one by one until we completed the marine engine mechanisms we are now using. The chain drive mechanism is being adopted for more and more machines needed in modern times. Machine designers are applying chain drive to high-power, high-speed drives hitherto considered impossible for roller chains. How to meet still heavier loads and still higher speeds confronts roller chain designers. The roller chain's ability to transmit power as accurately as gears to rotary shafts at long distances is inspiring its continuous development. At present, chain drives capable of transmitting more than 1,000 horsepower and enduring 7,000 revolutions per minute are in practical use, and the fields of their application are expanding. Numerous types and sizes of chains and sprockets are being manufactured. let's see the problems confronting chain drive mechanisms. The first question, to what extent can roller chains resist impact? This is a braking test to prove the shock absorption of the chain. A fatigue test continues day and night in the research laboratory. Here, a roller chain subjected to constant vibration is stretched repeatedly until it breaks. The SN curve is obtained when the chain is finally broken after hundreds of thousands or millions of stretchings. These curves indicate the best chain for each purpose and provide valuable data for increasing fatigue strength. This is noise analysis. Devising quieter chain drives is an important goal. A non-stop endurance test. Increased wear resistance of the roller chain depends upon greater heat treatment. To ensure high surface hardness, parts of the chain are gas carburized and quenched. The hardened surface increases the wear resistance of the parts. Wear resistance of the pinion sprocket teeth